Current electricity. Well, we talked about static electricity in our last series. This is series 2 on current electricity. Electricity occurs in two different forms. Static, which we talked about, is stationary. Brush your hair, wool socks, tumbler in the dryer, and then we have current. Current flow around circuit. Turn on the light and there's electricity. Walkman, all your music stuff is electricity. Static electricity review occurs when material which are insulators, rubbing, adding or removing of electrons. Objects become charged. Like objects, as we said, like before, light objects repel, unlike attract. Current electrical. Electrons flow through a conductor, negative to positive. Circuit equals continuous loop for electrons to flow. Need an energy source, a power source, energy user. Here's an example. We have a battery, which is the energy source. We have electrical load, a switch, and the wires, which is where the electrons flow from throughout the circuit. Electrical components. You have a wire, you have an ammeter, a battery, a fuse, conductive wires, bulb, switch, voltmeter, and resistor. Here are some symbols. I'm going to actually do a little more symbols after this one. A straight line means wire, conducts electron. So what we're going to do, we're actually going to design some circuits later on in the series, but these are just giving you some brief things of the symbols. Power source, the battery, electrical source is by the next symbol. That's, let me just get the nose here, this one. This one here is a lamp, when it has like a little squirrely thing inside in a round circle. Is a light lamp, light bulb. Resistor is a jagged end, that's a resistor. Switch has a broken connection, which this lever can come down and then it completes the circuit. So it can close the circuit. When it's up, it's open. So it's on-off switch. Ammeter is a little A. Voltmeter is a V. Series circuit has a single loop of electrons to travel around. Components are connected one after another. Current has to travel through all the components. Current is the same at all points. Voltage is shared between the components, so they have to share the voltage, so the voltage is not the same, it's actually less. Now here's the switch. We have 1, 2, 3 load, which is 3 light bulbs, all in serial because they're hooked up 1 to 1. If you can see one connection here to another, to another, to another, and then back to the battery. This is how we draw that example. Power source, one load, lamp, another load, another third one, back to the power source. This is an example of a one load and a switch. How we're going to represent it electronically is we have a switch, we've got the load, and we've got the wire to the power source. Parallel circuit has 2 or more paths for electron to flow down. Current is shared between the branches. Sum of the current in each branch equals total current. Voltage loss is the same across all components. Example, we have the battery going to this lamp, continues back out, also from this lamp, continues back. So you see, it actually has a loop here and a loop there. So every time we complete a loop is serial. So we've got like 1, 2. When you've got more than one loops, you have basically a parallel circuit. How can we represent this by diagram? Is by, here we have, well, let's go from the battery source. 1 complete, go back again, 2 complete, 3 complete. So at this thing here, we have 1 path, 2 path, 3 path that current can flow. Current is equal to the symbol I. Current is the flow of electrons around a circuit. Electrons flow changes direction 50 times per second. Here is an ammeter. We've got from the battery to the amp, battery to the bulb back to the amp. So to measure the amount of amperage this circuit is using. Measure current amp. The unit equals amp is 8. Current is flow of an electron. Connect in series at this point as you wish to measure. Red to red, black to black, the wires when you're doing this setup. Voltage, gain or loss of energy as it passes through components. Gain or loss of energy as it passes through components. Voltage loss equals voltage gain. In series, voltage loss is shared between the components. In parallel, voltage loss is the same across all components. A voltmeter, measure volts. Unit equals V. Voltage is increased as it passes through energy supply. Voltage decreases as it passes through the users. Connect in parallel around a component. Let's look at the example. We have in series, in parallel, right? So this is in series, in parallel, the current, the voltage. Always the same in series. The branch shares electrons and add to its total. In series, the voltage from the source equals voltage used. Voltage is shared between power users. This one, voltage is the same in all the branches. Resistance. The amount that a component slows the current is called resistance. Resistance is R. So the amount that the component slows the current is resistance. As the electrons are slowed by the resistor, energy is lost in the form of heat. So the difference that it loses gets dissipated into heat energy. This means the current, the resistance, and the voltage must be linked. According to Ohm, this is Ohm's law, voltage equals V equals I times R, which is voltage equals current times resistance. This is the formula. So we have V equals I times R. If we want to get current, it is current divided by voltage over resistance. You want to find a resistance, resistance is the voltage divided by current. The unit of resistance is called ohm, Greek symbol. Now there's other types of fuel. Fossil fuel. Fossil fuel is a fuel they use, gas, which is, they use petroleum that they dig up through the ground. And this is also used for generation of turbines, power generator, turbines and streams flow of water. Hydro dam, it has generators, as the force is so powerful going down the river which they dam up. They have turbines that it turns, and the faster it turns creates more electricity. Hydroelectric plant, hydroelectric, they have transformers, generators, and which sends the power to your house. Nuclear power is splitting of atoms and creating fusion and fission and creating electricity. Wind power is turbines that they have. The wind turns these windmills and it creates electricity. Tidal power, which is kind of interesting, the same concept as wind except no wind. You put the turbines deep underneath the ocean. The current is so strong that as the current passes, it pushes these turbines and it creates electricity. So this is another form of electricity from underneath the sea. Okay, so basically this is our introduction to current electricity. So this will give you, we talked about static, we talked about electricity, and it gives you a good intro. So we thank you very much and watch for our next series.